Okay. So now next, antenna. Antenna is a passive device. Okay, because you may have this confusion in general. You may think that antenna is a active device, but antenna is not a passive device, because just because antenna is having gain, it doesn't mean that it is active device. Because you might have been told, like, if some device, electronic device, is having gain, then that particular device is called active device. But here the definition of gain has been defined in some different way. So that's why antenna is not a active device. Antenna is simply a passive device. Okay. So again, what is antenna? Antenna is a transducer. It converts energy from one form to another form. Antenna is a transducer. Okay, antenna is a transducer. Okay, it is a transducer. Okay, what is a transducer? Is a transducer means it converts energy from one form to another form. Okay, so then what is transmitting antenna? It converts electrical signal into electromagnetic waves. It converts electrical signal into electromagnetic waves. Similarly, what is the receiving antenna? It converts the electromagnetic wave into the electrical signals. Please remember, sometime the antenna that you are using it for transmitter can also be used it for receiver sometime. Okay, in some cases you might have really different antenna for transmitter and receiver, but most of the cases the antenna that you have designed may act as a transmitting antenna or a receiving antenna. First of all, what is antenna? Antenna is any open circuit line can act as an antenna. Okay, any open circuit line, very important. Any open circuit line can act as antenna. Can act as antenna. Any open circuit line can act as antenna. That means sometimes the antenna that you are designing may act as a transmitting antenna, receiving antenna. That means whatever the definition characteristics that you are studying for one antenna, say transmitting antenna, that is almost same for receiving antenna also, except some parameters, except some characteristics. Okay, most of the characteristics is similar for both transmitting and receiving antenna in general. Okay, next, first the basic one is isotropic radiator. You know, isotropic means in all direction. If you are having some antenna, if it radiates uniformly in all 3D direction, that particular antenna is called as isotropic radiator. See, I am not mentioning all direction, all 3D direction, all the possible 3D direction, but practically it is not existing. Practically it is not existing. For example, if I have antenna here, my power will be going in all the direction. My power will be really going in all the direction. Now I am showing it in 2D only, but please imagine in 3D. Okay, just like I am inside the center point of the ball. Okay, from the center point of the ball, if the energy is going outside, okay, in all the direction, like that you have to assume. Okay, so energy is going in all the direction, all the 3D direction. Okay, then that particular antenna is called isotropic antenna because it radiates uniformly in all 3D direction. It radiates uniformly in all 3D direction. Okay, yes. So the whatever the antenna that we are using, practical antennas, is it isotropic antenna? It comes under isotropic category or non-isotropic? In practice, in day-to-day life, we are using antennas. That antenna comes under isotropic category or some other category?
Non-isotropic.
Non-isotropic, yes. So that's why, because here itself it is mentioned, because the practically not exist. That means what? All practical antenna is non-isotropic antenna. All practical antenna non-isotropic, because practical antenna will radiate energy only in particular direction. Practical antenna will radiate energy only in particular direction. Only in particular direction. Next, we will see what is directional antenna or practical antenna. Okay, so the example for isotropic radiator is a point source. Okay, a point source, because you know from the basics of electric field, once if you have the point source, it has the ability to radiate the electric field in all the possible direction. Okay, spherically, radially outward from the center point of the sphere. Okay, the best example is point source.